So thank you. I hope you're okay. It's not the night time. So I did a presentation with a lot of videos, so you can follow and not fall asleep. Okay? So my name is Sylvain DUPIRE. I am a research engineer at INRAE, which is a National Forest Institute, National Research Institute on Food, Agricultural and Environment. I work here in Grenoble in the lab called LESSEM, which is a laboratory about mountain ecosystem and society. I work on several topics, such as forest fire, but now I will just speak about protection forest against natural hazards and address you some aspect of it and some research we are doing on it here in Grenoble. Okay. So here's the presentation outline. I have a few slides of context. Then I will focus on how forests mitigate and natural hazard, which is rockfalls, which is the main topic we are assessing here in Grenoble. And I have also some slides on how this particular nature-based solution is efficient but also vulnerable due to climate change. So a few slides of context. In fact, we are using forests to mitigate gravitational natural hazard since a long time in France. In fact, it started at the 19th century, where the constat was made that only 10% of the area in the Alps was covered by forest, mainly because there was a lot of people and a lot of agricultural activity. And then from this time, we had a lot of very big events of flash flood, erosion, etc. So a new service was created, which is called Restauration des terrains de montagne in French, or mountain land restoration in English. And this service has the mission to assess this gravitational hazard. And they use for that a lot of reforestation because they say that it's an effective and sustainable way to mitigate the hazards. So the French state carried a lot of forest, about 400,000 hectares, and a bit more than half was planted and became the Forêt domaniale RTM, which are state-owned forests with only purpose to reduce the risk. I had some sample of them. Here is one for flash flood in the southern Alps in the left picture. You can see which was taken in at the end of the 19th century. It was only bare slope. There is only a rock and no vegetation there. And you have a picture nowadays, and you can see there is more forest on it. So that's one of the samples of planted forest. More emblematic one is the plantation of black pine on Black Marl in the southern Alps of the French. Also, for avalanches, forests are interesting only in the starting area, where the tree can fix the snow and avoid some avalanches. So when you go to ski resort, you can see this kind of landscape with a patch of forest, some patch of forest which are here only to maintain the snow. And here is an example in the Haute-Savoie, so in the northern part of the Alps in France. And finally, for rockfalls that we have talked about a little bit this morning, there is not really a plantation specifically for this risk. But mostly, when you look at the picture in the beginning of the 20th century and now, in most part of the Alps, you had this kind of differences with, at the beginning, forests which were only at the top of the slope, near the cliff, and then on the bottom of the slope, you had agricultural and a lot of agriculture and few assets. At that time, when you live in this valley, you know that there is a rockfall falling from the cliff. The same picture now, you see that there is a lot of buildings there, and forests cover everything on the slope, so you don't see the rock anymore. And the people that are living there don't know that there is a risk of rockfall because they don't see it every day when they look at the window. But if you go in the slope and walk through the forest, you can see this kind of picture with some rocks that are stopped by trees. Nowadays, we have much more forest in the Alps, which is half of the area, more or less. And we did a work some years ago to identify the forests that may play a role against rockfalls in the Alps. And we had the conclusion that about 14% of the forest area play a role for this specific risk. And they are mostly located in the northern Alps. So speaking about rockfall, I will address a kind of inventory of what we are doing on research on this specific hazard and the effect of forest to mitigate this hazard. So what we do, that's the first video, so don't fall asleep. Don't start your nap now, it's becoming interesting. We had this kind of experiment where we throw rocks on the slope, and we have camera everywhere, and also the rocks have many sensors in it, so we can follow with precision the position of the rocks. And the aim of this experiment is to to understand what is the effect of topography, soils on the trajectory. It's also interesting to know what is the effect of the rock itself, of the big rocks, the shape of the rocks also. So that's some research that are conducted in another laboratory. But in my laboratory, we are interested in the interaction with tree. So we do also experiment at the tree level. The idea is to have a big tube in the slope in which we throw a spheric rock, and it eats a specific tree, the one we want the rock to eat. And these experiments are useful to understand the role of the different compartments of the tree on the transfer of energy from the rock to the tree. So if you see this video, you can see that the trunk or the stem play a significant role, mostly when it breaks. And you can see that the rock after that is really more slow. I have lost a lot of energy. Here you can see the effect of the roots on when a rock hits a tree. And another effect is a transfer of energy from the rock to the tree. And then you have this movement, like a hula hoop movement of the tree and the crown. And our research aims at to understand the influence of the impact on the rock trajectory, mainly how much energy it lost, what are the modifications of the trajectory, and also we want to know how each compartment contributes to the rock energy reduction. So from this experiment on site, we build models, like many scientists. And one of the models is at the tree level, and we reproduced the experiment by doing a model that where a rock impacts a tree. What is nice with models is that you can test a lot of situations and the parameters, and we conducted a study to know what are the parameters that are important to take into account if you want to accurately predict what will happen when you have an impact on a tree. And the results are here. For the tree, the main parameters that are important are the diameter and height of the tree, so the size of the tree, and also the density of the wood, because the more the mass you have to oppose to the rock, and the more you will reduce energy. There are also some parameters that are linked to the rock itself, so the speed and the volume. And then there is only parameters specific to the impact. It is a frontal impact, lateral impact, and the height where it hits the tree. At the slope level, we have also a model called Flat Rock, where so this model is able to model different trajectory phase of the rock. You can also model, you have different options. Either you follow the rock with the center of gravity, or you follow the rock by its real shape. You can model in 3D or in 2D. And for us, what is interesting is that all the work on the rock-tree interaction is inside the model, so we can do modelization with or without forest. Here is an example of the results of this simulation. On the left side, you have a simulation without forest, and on the right side, with forest. I highlight the different assets that are impacted in both scenarios. So the buildings are in pink and the road in blue. You can also see the reach probability for each block to reach a certain distance and some figure. But what is interesting here is that in this particular case, rock assets, the risk of the rockfall risk on the rock assets is divided by 3 thanks to the forest, so it's very effective. And also, if you want to build complementary civil engineering fence, by taking into account the forest, you can see that you will build civil engineering with a shorter length and also less height in the net, for example. So you will reduce the cost of the structure. From this slope model, I did some works during my PhD thesis to produce a method to be able to quantify the protective effect of forest against rockfall. And for that, I use many forest plots in the Alps. And for each plot, I did simulation with and without forest on a virtual slope. And the idea was to follow the distance where the rock slope where the rock stop along the slope, also the energy of the block along the slope, and to calculate some protective indicators that have all the same shape, which is a comparison of a variable with and without forest. From this equation, we produce 3 indicators. One, which allow us to calculate how forest is effective in reducing the frequency of rockfall. One, to follow the intensity of rockfall. So here we are interested in the energy of the block. And there is also a global indicator which take into account both frequency and intensity reduction. So what are the main effects of forest on rockfalls? From this work, we can say that there is 3 main effects of forest. One that we call the barrier effect, which it's only the fact that some rocks are stopped directly in the forest, and if you don't have forest, they go at the bottom. And this effect is linked to the impact probability, so the size of the tree and the number of trees. The second effect is the buffer effect, that when you have a forest on a slope, the energy of the rock will be reduced. And this effect is mainly driven by the tree size. And the last effect is somehow logical, is a cumulative effect. The more the slope, the forested slope on the slope, the more you have forest on the slope, and the more the forest will be effective. So there is a lot of schema, but I will just focus on some ones. I also was interested in how effective is the French alpine forest, so I followed this this indicator, which is the length of forest needed to reach an overall rockfall protection index of 99%. And I just watch at the proportion of the forest plots that are between the protection class and which are interesting. So, for example, we have 60% of the forest in the French Alps that have a high protective effect after only 200 meters of forest, so it is very a short distance. But we have also 20% that have a low protective effect, even after 600 meters. So depending on the forest you have on the slope, you have a big difference on the rockfall mitigation. Another conclusion of the work is that when you look at the diversity, the impact of forest diversity on the effectiveness of protection, what we have seen is that the more the forest is chaotic in summer, and the more it protects against rockfall. For example, if you have a forest with a lot of small trees, medium tree, and big tree, it will be more effective than forest with the same tree everywhere. That's also good for biodiversity. And finally, these forests are effective, but as you know, they can be disturbed by a lot of phenomena, such as pest, storm, or drought. Or, like we have seen this morning, some fire. Here in Isère, we have, as said by the commandant this morning, we had a big fire in 2003 and also in 2022. And each time the same cause produces the same effects, that we observed an increase of rockfall activity after fire on the site where the fire occurred. So what we do at the research level to understand and anticipate the effect of disturbance on the protective effect, we started this year a big campaign of on-site experiment to measure mechanical property of tree. These are called pull and release experiments. The principle is to pull on the tree with a constant force to maintain the force, and during this time we can measure the root stiffness and the trunk elasticity, and then we release suddenly the tree. So that's what you can see on the video there. And from the frequency of vibration of the tree, we can deduce a lot of information, and notably the distribution of the mass during the trunk and the crown. So we did this experiment in different conditions. The idea is to compare mechanical parameters between healthy tree and disturbed tree for different disturbance. We did that here in Savoie, in Villars-Gondrin 5, which concern only larch Larix decidua tree. And we compare several parameters, and there you can see the influence of the change of the parameter on the ability of the tree to reduce rockfall hazard. So for example, for wood density, we can see that when you have a fire, all the dead trees have lower density than the healthy trees, mostly because they lost the water that they have inside. And that has the consequences that there is less mass to oppose to the rock. So when a rock will hit a tree, you will break more easily the tree. Concerning the root stiffness, we have seen that in this particular case, we reduce the root stiffness by 15% after a fire. So what it means, it's easier to uproot the tree if you have a rock impact. And for the last parameter, concerning trunk elasticity, so the ability of the stem to deform when it gets a tree, we can see that in this time, dead tree have a better parameter than alive tree. So this means that it's harder to break a dead tree, a burnt tree, than an alive tree. When you know that, you can inject this conclusion into the rock impact model, and then afterward at the slope level, and you can see what are the influences of this particular risk on the protection, the protection effect of forest. This part we didn't start now, so I can give you results, but these are the next steps. That's all for me for the morning. If you have any question, it's okay to start.